Hi. Section 10.2 is kind of like Section 10.1, where it's just a lot of definitions and kind of introducing ideas. There's one formula, there are a couple theorems. So this is more new, though. I mean, you might have done some of this before in in a pre-algebra class or something, but it's definitely newer material than last section was. So measuring angles and arcs. All right. So first of all, we've talked about angles before, and we talked about congruent angles. But now we're going to talk about some definitions of central angles, major arcs, minor arcs, and semicircles, and then find their angle measures, and then find arc lengths. And that's going to be important for us. We're going to do arc length versus arc measure, and those are two different things in this section. So you have to keep track of which one they're asking for. So first of all, central angle of a circle is an angle with the vertex in the center of the circle, and its sides are radii. So angle with a vertex at the center of the circle and its sides contain two radii of the circle. Okay. So for us, angle ABC is a central angle. The book talks about this idea that a degree is 1/360th of a rotation. Okay. That's because we define arc angles actually by their central angles by their measurement with relation to 360. So if you have all three central angles or all of your central angles, you could have 5 or 10 of them. Excuse me, all of them should sum to 180, or sorry, not 180, 360. There we go. They should all sum to 360. Okay, so here's our first problem. Solve for x. So they want us to figure out the measure. Excuse me, figure out the measure of x in this problem. Okay. Whoops, wrong button. All right, so I've got this guy here. This is three central angles. Um, X, 145, 165. Some of you might be the type of person that says, oh, okay, I know all of them have to add up to 360. That's fine. Some of you might be a little more intuitive and say, well, let me just add these two guys together first. That gives me 310 degrees. Either way, it doesn't matter to me because you're still going to subtract 310 from 360 in the end to get 50 degrees for X. All right, next. Now this is something that is a little bit different. Okay, we're going to have to talk about this in two different ways. Right now we're talking about arc angle measure, or arc measure, not arc length. Okay. So in this drawing here, the definition of arc is a portion of a circle defined by two endpoints. Okay, so you've got endpoints P and R. A central angle separates the circle into two arcs with measures related to the central angle. Essentially what it is that the arc angle equals the central angle. Okay. So if we go back to this previous problem here, if I looked at the arc formed here, it would be 145 degrees for its arc angle. This arc angle is 165 degrees. This arc angle is 50 degrees. Because whatever the central angle was, which was 50 here, that's the measure of the arc angle. Now we'll talk about arc length later. Now, there are three types of arcs, and this is something that's easy to mix up and get confused with. If, okay, the book says minor arc is the shortest connecting two endpoints on a circle, shortest arc. The key basically is that the measure of a central angle, or sorry, minor arc is less than 180 degrees. Okay, and it is equal to the central angle. So if this is 50 degrees here, arc AB is 50 degrees. The major arc is the longer of the two. And one way to think of it is it's the rest of the minor arc. That's what a lot of textbooks like to do, is to say it's the rest of the minor arc. Basically, I like to think of it as greater than 180 or equal to 360. So basically between 180 and 360. The way the book likes to define it is you take 360 and you subtract the minor arc. So if this is 50 degrees, you do 360 minus 50, it gives you 310. That's okay, but I just prefer to think of it as it's the rest of it, which is what you're really doing. And then a semicircle is an arc with its endpoints that lie in the diameter. Okay. And the measure of a semicircle is always 180. Now, some of you might be saying, well, how in the world do I know if I have a minor arc versus a major arc? And that's a good question. The key is a minor arc has 2 letters for its arc. The major arc has 3. And the reason there are 3 is it tells you really where to go. If I'm going to go with minor arc AB, okay, I'm going to go the smaller one automatically. But if I say AB, I could also talk about maybe I'm going around this arc this way. Well, that is where we bring the third point in and say, no, start at A, go through D, and that's how you'll get to arc. That's how you get to point B. That's your minor. That's your major arc. Okay. Semicircles also have 3 letters because of the fact that we need to know which way we're going. Are we going A to B this way or A to B this way? And since they've included D, they want to say, nope, go A to D to B. So there's your semicircle, and again, it uses 3 letters. That's not a very good color, is it? Major arc uses 3 letters. Minor arc only uses 2. So minor arc less than 180 with 2 letters. Major arc between 180 and 360, 3 letters. Semicircle is 180, 3 letters. In fact, you kind of think of a semicircle as a specific type of major arc. So here's the first example. I'm just going to walk through these real quick. The question is identify each arc as major, minor, or semicircle. So you'll have 2A pop up, 2B pop up, and then 2C pop up separately. So yeah, so 2A, 2B, and 2C. Okay, so we go to the drawing then to look at these. 2A should have been a dead giveaway to begin with. You're going from M to Q, but it's only 2 letters. So it means I can't go through N or P to get to Q. I just go this way. So MQ is a minor arc. Okay. Now 2B is either major or it's a diameter. Same thing for C, either major or diameter because it's got 3 letters, M, N, P, M, N, Q. So let's look at M, N, P. Start at M, go to N, stop at P. So the question becomes, where are the endpoints? Are they on a diameter or are they just out in space? Well, here they are, M and P. MP is the diameter. They even tell us that PM is the diameter. So 2B is a semicircle. Okay. And then 2C is from M to N to Q. I'll just do that in red because I'm kind of running out of letters. M, or colors, I mean, to N to Q. Not a very pretty one, but it is what it is. And it's over 180 because it's past the diameter, plus it's what's left over from MQ taken out of it. So this is a major arc. Okay. All right. Now congruent arcs. Congruent arcs. Theorem 10.1. Okay. 2 arcs are congruent if and only if their central angles are congruent. Okay. So if they tell us that 1 and 2 have the same angle measure, we know the arcs are congruent, and vice versa. If they tell us that arc F and G and J and H are congruent, that means those central angles are also congruent. Arc addition postulate. This works just like angle and segment addition postulate. If I add XY and YZ together, those two guys will add up to the same thing that arc XYZ would be, which if this is 20 and 30, 20 plus 30 is 50, which should make sense. If for some reason they didn't add to each other, we got something really, really weird happening. And then the last part is arc length. Okay, finding arc length. Just a second, pause this. Okay, I just realized I made a mistake. I have to jump back for a second. I'd have a problem in here that I skipped to show you. So I think it should be on your sheet, but here it is in the value here. So we're supposed to find the measure of arc BCD, and that means angle, not the arc length. Whenever it does measure with little m like this and line over it, that means angle measure, not length measure. So the question is BCD. Well, let's see where BCD is. Well, here's B to C to D. Okay. Now in order to do that, we have to know these 2 arcs. are those two angles. And we can add them together. Well, I know this guy here is 90 degrees, so that's easy enough. The question really is, how much is this guy here? Well, there's two ways to figure that out. One is to realize that if this is 90 degrees, so is this, and then that guy 38 and this have to make a right angle, which makes this then 52 degrees. Those guys form a pair of vertical angles, so they're also congruent, so it's 52 degrees. So I can just add that together. 90 plus 52 degrees ends up being 142 degrees. Okay. The other way you could have figured it out, and this honestly is the way I would have done it if I didn't use the arc addition postulate, is just realize, hey, wait a second, this is a semicircle. Okay. Well, that's 180 degrees. And I'm going to take off 38 because that'll give me the rest. 142 degrees either way. All right, so now we'll go back to arc length. The book does two things here. It does a proportion and an equation. To be honest, I like the equation better. I think it's easier to use as far as when you're just finding an arc length. But I do like the proportion if I'm solving for maybe, say, the angle or the radius or something like that. The book's a big fan of doing that. So it just depends upon what you're doing. So the ratio of the arc length L to the circumference is equal to the degree measure of the arc to 360. Okay, so let's go back here and I'll show you what that means real quick. So I've got here this circle. Okay, so what I have is its central angle right now is 113.86 degrees. The arc length is not the full circumference. That's because in order for it to be the full circumference, that central angle has to go to 360. So as you can see, I'm getting bigger and bigger, getting closer to 360. I'm almost equal to that guy. I'm going to run out of space here real quick, but you can see 359.76. That's almost 360 degrees. Arc length is almost a circumference. And if I want to know what semicircles is, make it go half the measure. At 180 degrees, it's really half of the circumference. So the formulas work by basically kind of making that note that, hey, arc length is really just a portion of the full circumference. And so they give us two formulas for that. So we'll look at a problem and I'll kind of walk you through the formulas with those. Okay. Yeah, so here we go. So I want to find the length of JL, arc length of JL. Well, I know the radius. That's good. Okay. So what I really need to know, though, is the measure of the central angle of JL. And I'm talking about the minor arc because it's only two letters. Well, if this guy's 22 degrees and this is a whole diameter, it's the rest of it, which is 158 degrees, because together they make 180. So there are two ways you could do this. You could say to yourself, okay, the arc length over the circumference equals the arc angle at a 360. That's one way to do it with a proportion. I don't know arc length, so we'll call it x. Circumference, well, circumference is just 2 pi times the radius. Which is 30 pi. No, sorry, not 30. It's 14. Come on, Mr. Moyer. So 28 pi. Oh, darn it. No, close enough. 28 pi. Arc angle is the central angle, 158 over 360 degrees. Okay. So I could find the arc length then by just doing cross multiplication. And, you know, don't know if you ever caught the trick that it's just multiply and divide, cross multiply and divide. So 28 pi times 158 is 13,898.4059, but then divide by 360. Then you get 38.61 because it did say nearest hundredth. And it's what, centimeters? Yeah, centimeters, 0.61 centimeters. Now the other way to do it is this, and this is to solve for the arc length. It's going to be the angle over 360 times the circumference. That's the other way the book does it. It's that second formula. This one's nice if you're going directly for the arc length, because then you just plug in the angle and you plug in the circumference. And how this works is, it says, okay, well, what's your angle? 158 over 360. That's the fraction that you are of the full circumference on whatever 158 over 360 is fraction-wise. So then multiply that by the circumference, which was 28 pi. So I just get my little calculator out. I'll do the same thing. Of course, if you do this on the calculator, you've got to make sure you put parentheses around the 158 times 360. Oops, which I almost didn't do. I told you to. 158 divided by 360. Divided, or times 28 pi, which gets us 338.60, same exact answer as before. So the proportion is nice because you can just cross multiply and divide. The angle formula is nice because if you're looking for the arc length, it's just one calculation in the calculator. 158 divided by 360 times whatever the circumference is. Okay. And that's it for section 10.2.